Hello everyone. In this video, we are going to be discussing about model evaluation. So in this phase of our data science methodology, we are evaluating the performance of our model that we had trained previously on the training data set, and we will see how it works in real world environment, that means upon the unseen data, and see if it is effective or not, or if it is making the correct predictions. There are some evaluation metrics that are used to calculate the efficiency and evaluate our model. We will discuss this one by one. First is accuracy. Accuracy is nothing but the proportion of correct classifications, and the opposite of accuracy is error rate. Error rate means the proportion of incorrect classification. It can be calculated by subtracting accuracy from 1. Next, moving forward, we have sensitivity. It means the ability of model to classify record positively, and specificity, which means the ability of our model to classify the records negatively. We can understand this by some examples. For example, we have a model that is going to predict some kind of responses, and these responses may either be true positives, false positives, true negatives, or false negatives. That means either it is going to be positive values and either it is going to be negative values that are present in our training data set. Now, there are chances that our model may predict a positive value as positive. That means it is a true positive. But there may be a case when it predicts a positive value as a negative value. Then in case, such instance would be called false positives. True negatives means the instances that are actually negative and our model has predicted them negative as well. False negatives, it means the instances that are positive but our model has predicted them as negative. Now if we will see the terminologies that are related to all these terms, we have precision, which means the proportion of true positive predictions out of all positive predictions. For example, in our model we have all the positive instances and negative instances, means our data set is into two parts. So all the proportion of the true positive predictions out of the all positive predictions that are present in our model. So that is the precision of our model. And recall is the proportion of true positive predictions out of all actual positive instances. That means according to some kind of query, how many predictions that are actually turned out to be positive and are in turn returned by our model as output. That is the recall. That means we are having here the true positives plus false negatives, and here we have true positives plus false positives. That means according to the model we are talking about here, how our model has predicted the positives. And in the recall, we are actually talking about the actual number of positives that are present in our data set and comparing it with the true positives that our model has returned. Then we have F1 score, which is harmonic mean of precision and recall, which can be useful for imbalanced data set. And another important concept we have here is confusion matrix. That is a table that is used in our coding that we can use to have the true positives, true negatives, false positives and false negative values on our screen according to our code. The next topic we have here is accounting for unequal errors. Accounting for unequal error cost means that we recognize the different types of classification errors that may be in our model under the different consequences. For example, in many real-world applications, the cost of a false positive may not be the same as the cost of a false negative. It means the extent of how much a model can affect the real world situation for the problem we are trying to solve. There are types of error we have. Here is false positive, that is type 1 error. It means the model incorrectly predicts a positive class when the true class is negative. And false negative means the model incorrectly predicts a negative class when it is true class is positive. And here are the example. Medical diagnosis, it means that diagnosing a healthy patient as having a disease, and in false negative means we diagnose a patient that actually has a disease as a healthy person. When implementing in our code, we can use the cost metrics and class weights in our coding to implement for the unequal error accounting. So cost metrics are quantitative measures that help assess the financial or practical implications of the errors made by a model. They provide a way to evaluate model performance beyond traditional metrics like the accuracy, precision, etc. that we had discussed earlier. The traditional metrics, the ones we discussed earlier, may not actually discuss or tell us about the cost related, means the extent of effect the error is causing our real world situation. Now we are going to see here the model evaluation. Now we are going to see the example of model evaluation in our previous code. So I have implemented the model evaluation for the random forest we made earlier. I am using the sklearn library and calling the metrics module. The metrics module has many kind of functions such as classification report, confusion metrics, accuracy score, and many more that can help us evaluate the performance of a model. So here we are evaluating our model. First we are making a confusion matrix and we are predicting it with respect to our test data set and predicting data set. We would run this and we will run this one as well. Here we have confusion matrix and classification report and accuracy store. So this is how a confusion matrix will look like for our random forest for the previous question, and the classification report and accuracy is also given here. As we can see, the accuracy score is 0.97, which means the algorithm works very fine on our dataset. That was all for this video. Thank you.